Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arifpat.me. The other way is to download the notebooks from course GitHub account arifpucat, and all the notebooks of this course are housed in this public data science repository. Well, this is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 7.1 of the 7th module, overview of natural language processing, for the course titled Tools and Techniques for Data Science. Well, today is the first session of this module in which I will try to set the stage right for our upcoming sessions that will provide an overview of some of the contemporary methods, techniques, and research topics within the field of natural language processing. Well, my dear students, in simple words, NLP enables computers to understand and respond to human languages in written, verbal, and signed form. It is a subfield of linguistics, computer science, and artificial intelligence in which you write programs to teach and train machines so that they can understand human languages in text and spoken form and can perform actions based on the commands given to them. Well, this startup screen contains a lot of randomly placed images that I have taken from the internet describing different concepts related to NLP. Well, this upper portion of this image shows that most of the NLP programs takes unstructured text as input and make use of libraries like NLTK, Spacey, Gensim, TextBlob, and so on to perform syntactic and semantic analysis of the text to determine its meaning and transform it to some structured text or maybe instructions that machines can understand. Well, in the left half, these images describes different real-world applications of NLP. This right half shows the difference between natural language understanding and natural language generation. The three approaches that we use to solve NLP problem, namely heuristic, machine learning, and deep learning. And over here, I've shown a generic NLP pipeline, which is a set of steps that we follow to build an end-to-end NLP software. My dear students, in today's session, I will give you an abstract overview of all these concepts, which is really important before we do the text pre-processing, feature engineering, and apply the heuristic, machine learning, and deep learning approaches to solve some basic NLP problems. So let's move on to the learning agenda of today's session. First of all, I will spend some time to give you an overview of NLP and the challenges that we face in natural language understanding. Then I will give an abstract overview of some of the real world applications of natural language processing. After that, we will understand the three approaches used to solve different NLP use cases. And finally, I will try describing the 6 phases of our generic NLP pipeline. So it will be a bit theoretical session, and of course we have a lot to do. So let's start playing. So once again, NLP enables machines to understand and respond to human languages. And I think there are over 7,000 languages spoken in the world. Not only the count of these languages is increasing every day, but they are also evolving with every passing day. And the main challenge to understand human language is that at times their sentences are ambiguous, even for humans. Can any one of you tell me the correct meaning of this sentence shown in green over here? I saw a student on a hill with a microscope. Well, there can be different interpretations of this sentence. First can be uh, there is a student on the hill and I watched him with my microscope. Second can be there is a student on the hill and he has a microscope. Third can be I am on a hill and I saw a student who has a microscope. My dear friends, such a sentence can even confuse a human, so it is real challenge for computers to understand the meaning of such sentences. Well, the two main components of NLP are natural language understanding and natural language generation. In these sessions of ours, we are mainly concerned about natural language understanding. And for that, a machine needs to perform uh, some analysis techniques which are shown over here. Uh, these are the analysis techniques which I want to talk about before moving ahead. This phonological analysis or phonological knowledge is essential for speech-based systems as they deal with how the words of a language are related to the sound. Since the objective of these sessions is to give you an overview of NLP, so our discussion on representing and analyzing human speech signals, of course, is beyond the scope of these sessions. However, we will of course see how to represent textual data and perform analysis on it in order to design and build situations or solutions for different NLP problems. Okay, let me quickly give you an overview of these six terms in relation to textual data. Uh, in simple words, this morphology is actually the study of word formation. That is how words are built from smaller pieces, like language morphemes and other linguistic units, such as root words, affixes, parts of speech, and so on. This lexical analysis reads the text and convert it into meaningful lexemes called tokens. This syntax analysis actually takes the tokens generated by the lexical analyzer and generates a parse tree. So this syntax analysis generates a parse tree. This is actually a study of how words combine to form phrases, how phrases combine to form clauses, and how clauses join to make sentences. It actually uncovers the grammatical structure of a sentence. Then we move on to the fourth one, that is semantic analysis. Semantic analysis actually checks whether the parse tree that is generated by the syntax analysis follows the rule of the language or not. It is a study of context independent meanings of words and sentences. Remember, semantic analysis deals with the study of context independent meaning. On the contrary, this pragmatic analysis is an extension of this semantic analysis, and this is a study of context dependent meaning of words and meanings. So, pragmatic analysis involves the context. And finally, this fifth is the disclosure integration, which deals with how the immediately preceding sentence affect the interpretation of the next sentence. My dear students, in in the later part of the course, these six analysis techniques will, of course, be very important because we need to, if we want to deal with the challenges of NLP, we need to have a very clear understanding of these analysis techniques. Uh, Let me once again fall back to the challenges faced by machine while it tries to understand natural language. Uh, uh, I will call it ambiguities over here, which means more than one meanings of an individual word or of a sentence as a whole. And let me describe these ambiguities one by one with examples so that you can understand these analysis techniques as well. Okay, first of all, consider this sentence. I voted for Imran Khan because he was the most aligned with my values. Well, in this sentence, the word I and my belongs to one person, while this word Imran Khan and he belong to another person. This may be very simple to understand for a human, but difficult to understand for machines. Well, this is called referential ambiguity, which occurs when you mention an entity and then refers to it again using some other word. In this sentence, I over here, he and my, they are pronouns, and it is difficult for a machine to understand which noun they are actually referring to. Inshallah, in some future session, we will learn a technique called co-reference resolution to resolve this referential ambiguity. Now consider these two sentences. Arif is swimming against the current and I need new batteries for my house. Being human, we know that the word current over here means the direction of flow of the river and not the electric current. Similarly, in the second sentence, the word mouse means a pointing device used in computers and not the small mammal that is found in old houses. Well, such an ambiguity is called a lexical ambiguity because the lexemes or tokens, this current and this mouse, have more than one meanings and they need to be interpreted differently based on their contextual sense or the correct sense. We can resolve such ambiguity to some extent using part of speech tagging. The technique used to resolve this lexical ambiguity is called word sense disambiguation, which is a natural classification problem used to determine the correct sense of the word in a particular context. Inshallah, we will see this as well in our some future session. Let me move on to the next type of ambiguity, and that is the syntactical ambiguity. Consider this sentence. I shot an elephant wearing pajamas. Hmm. Well, this sentence has both lexical as well as syntactical ambiguity. The lexical ambiguity is due to this word shot, which can have two meanings, a camera shot or maybe a gun shot. The syntactical ambiguity is who is wearing the pajamas, myself or the elephant. Well, the syntactical ambiguity is also called a grammatical ambiguity, which occurs due to the structure of the sentence. And this syntactical ambiguity exists if the parse tree is generated based on deterministic grammar rules. And the solution is to use neural network based parsers. And probably I will not be touching on that in this module. We will inshallah ta'ala see the neural network based parsers in the deep learning module of ours. Okay, next is semantic ambiguity. My dear students, syntax is the study of the sentence structure and the rules of grammar. On the contrary, semantics is the study of meaning of sentence. If you consider this sentence, Arif and Khurram are married, the ambiguity is uh, that are they married with each other or they are married, they are just married. And the problem over here is due to this word married, which if taken out of context, gives you two different meanings of the same sentence. And the solution, of course, of this is a pragmatic analysis, which will give context dependent meanings using the real world knowledge. Okay, anaphoric ambiguity occurs due to a phrase referring to something previously mentioned and there is more than one possibility. The example sentences makes this concept clear. I watched a guy do 50 push-ups. Can you do that? The second sentence may mean over here, can you do 50 push-ups? Or it may also mean, can you also watch a guy do 50 push-ups? So this is anaphoric ambiguity. You may come across colloquialism and slangs in your sentences. Consider this sentence. Working on Linux shell is like a piece of cake for me, but playing football is not your cup of tea. So this is another barrier in natural language understanding. My dear students, I have tried my best to make you understand the linguistic issues or challenges that you will come across in the domain of NLP while making the computer understand natural language. Now let us change gear and move ahead and discuss some real world applications of natural language processing. And even before that, let me tell you that all natural language processing tasks can be broadly classified into these five categories: machine translation, information retrieval, sentiment analysis, information extraction, and questioning answering systems. Okay, first of all, the simplest and the most common real world application of NLP is spam email filtering that uses text classification techniques. My dear students, when you receive an email, the spam filter analyzes the content, and if it is classified as spam, it put it in the spam folder, and otherwise it put it in the inbox of your email. This is the most practical example that we all have seen while using the Google product Gmail. And of course, the smart reply of Gmail is also another example of NLP. Second most common application is sentiment analysis, also referred to as opinion mining, which is used to identify the emotional tone behind a body of text or maybe a verbal speech. It can be as simple as detecting positive or negative sentiments in text and maybe extended to detect specific feelings and emotions like happiness, frustration, anger, and sadness. If the polarity precision is important to your business, you might consider expanding your polarity categories to include different levels of positive or or negative. Instead of positive or negative, you say very positive, positive, neutral, negative, very negative, and so on. This is usually referred to as the fine-grained sentiment analysis. Okay, let's move on to the next application area. Uh, my dear students, this image describes information extraction, which is the process of extracting information from unstructured textual sources into more editable and structured data formats. There are a few examples, and let me talk about this fourth one over here. Excuse me. Consider this email text. Dear Arif, a faculty meeting is scheduled to be held on 21 September in library from 10 to 11 a.m. Please make it convenient to attend. Thanks. Uh, well, I want to write an application that should extract information from this email text like the event, rendezvous, date, starting and ending time, and I need to populate the calendar entry for a meeting. Well, to extract the information, you may need to build knowledge graphs using dependency parsing, part of speech tagging, and named entity recognition. Well, we will inshallah be covering these concepts in detail and build some basic application for for the above spam filtering or maybe classification of the tweets or some application like information extraction using Python libraries like NLTK and Spacey. Okay, fine. Google search engine is one of the greatest applications of NLP. Information retrieval is the process of accessing and retrieving the most appropriate information from text-based data based on based on a query given by the user. In this image, I have asked Google uh, which is the capital of Pakistan. Google not only ranks all the links of the web pages in which there are answers to this question, uh, but has also generated text that gives precise answer to this question of mine. This is what is called natural language generation, the second component of NLP. And we have discussed in detail the first, that is natural language understanding, before. So Google also tries to retrieve the answer from the most relevant and authentic website and gives you a precise answer, just like a questioning answering system. You can see the text of your answer written over here. And these are the generic steps that a questioning answering system performs. And the final step, that is answer, is given using natural language generation, which performs text planning, sentence planning, and text realization. I hope this is making a bit of sense to you. Don't worry about the terms that I'm using. Inshallah Ta'ala, you will be having a complete understanding of all these terms once we finish this entire module of NLP of ours. Let me move ahead. And this is another great application of NLP, that is identifying and correcting misspelled words, giving you suggestions as you type, and maybe the option to autocomplete without the need to type the rest of the sentence. I have attached a screenshot of Google search text box. You all must have used these functionalities while writing an email from your Gmail account as well. And last but not the least, Grammarly is another very common example application that uses these functionalities. Okay. Machine translation is another very common NLP application. Over here, I have attached a screenshot of Google Translate, which not only detect a language but also translate it in both textual as well as in spoken form. You can see how Google Translate has translated the English sentence "Welcome to learning with NLP with Arif" into a sentence in Urdu. आरिफ के साथ NLP सीखने में खुशामदीद. And observe that it is not simply translating word by word, rather has understood the overall structure and context of what is being said before translating. However, while translating this second sentence, "I shot an elephant wearing pajamas," Google said that मैंने पाजामा पहने एक हाथी को गोली मार दी. So even Google is still trying to solve the syntactical ambiguities. Okay. Uh, my dear students, 20 to 30 years back, a single type of advertisement was shown on televisions, mobiles, as well as on websites. These days, contextual ads are very common. For example, in this screenshot of a Yahoo News page, the user is reading uh, news about sports, and that too cricket. So the contextual ads are based on the context that the user is looking right now. If you own a website, it will just take 5 minutes to have contextual advertisement on it using Google AdSense. And if there is a lot of traffic coming on your website, you can make money from that. Let me move on to the next application of NLP, and that is text similarity or plagiarism detection. My dear students, this text similarity is the process of comparing or calculating how two words or maybe phrases or documents are close to each other. The most common application that uses the text similarity uh, is Turnitin. Some of you might have used it before. It is a great tool to identify plagiarism between student assignments and research articles. In some future sessions of ours, we will learn to do this by first transferring the documents into TF-IDF vectors and then computing the cosine similarity between them. The next application area is text summarization. My dear students, text summarization is a process of creating a short, meaningful description of a large document, as shown in this image. You can also apply it in image captioning, where NLP helps to describe an image and suggest a perfect caption for that image. The most common technique used for text summarization is latent semantic analysis. Another NLP application is topic modeling, in which uh, given a set of text documents, we cluster those documents based on their contents by topics like maybe science, politics, sports, religion, technology, and so on. In topic modeling, we use bag of word technique to vectorize the text and then use unsupervised machine learning by applying different statistical models like latent directly allocation or maybe non-negative matrix factorization. If time permit, I will try to cover uh, this LDA and non-negative matrix factorization technique in our upcoming sessions to perform topic modeling, inshallah. Well, authorship attribution is another NLP use case whose goal is to match anonymous text with its author via some similarity measurement learned from labeled text written by the same person. In simple words, we have a, uh, a set of documents and a set of candidates, and the algorithm is that we have to assign each document to an appropriate author. And once again, there are many different algorithms that can be used for authorship attribution, and the simplest of all is uh, a supervised machine learning approach using a naive Bayes classifier. My dear students, you all must have used recommender systems that give suggestions or recommendations to the users, uh, like uh, like buying a smartphone, listen to a specific song, or maybe watch a specific movie. A recommender system can use either or both collaborative or content-based filtering. Well, a content-based recommendation system try to recommend items that are similar to those that a user liked in the past or maybe uh, is examining currently in the present. Social media websites like Facebook, Twitter, and LinkedIn suggest its users the people you know or you should follow this algorithm recommendation systems. Similarly, Netflix also use recommendation system to suggest you to watch a specific movie based on your viewing history and how long you have watched different titles in the past. Maybe the movie categories you normally watch, the actors, and maybe your age and gender as well. So this is a common application area of NLP. Okay, chatbots. My dear students, chatbots, also known as conversational agents, is one of the greatest application of NLP. Chatbots are mostly used in the customer service domain because companies want to give 24 by 7 assistance to its customers. And there are three categories of chatbots. Simplest are uh, normally use fixed hard coded rules. Then we have flow based chatbots. You might have used them while ordering your pizza. And the hardest of all to design are open ended chatbots uh, that are domain independent. Okay. My dear friends, the most ultimate NLP applications are the voice assistants these days. You all must have used Apple Siri, Microsoft Cortana, Samsung Bixby, and Google Assistant in your computers or mobile phones. Well, instead of typing, you speak commands like open a browser, load a specific web page, or run a specific YouTube video, take a picture, maybe set an alarm, and so on. So instead of typing a query in the Google search text box, you can simply click the mic icon and say your question, and Google Voice will give you the answer of your query. Well, these days, voice assistants also come as special hardware devices that takes verbal commands from you, and control your house appliances, your cars, and you can also do a transaction with ATMs using your voice commands. Okay, my dear students, I think we have spent enough time in discussing the real world applications of NLP, and this is enough of motivation to learn and work in the domain of NLP. Let's see what is next. So now a $100 question is, uh, how to realize these real world applications. My dear students, these are the three techniques or approaches that one can use to solve different NLP use cases. The first is the heuristic approach, the second is the machine learning approach, and the third is the deep learning approach. Let us discuss and understand them one by one at an abstract level. Well, the history of NLP goes back to 1950s, and the only approach used to solve NLP problems at that time was heuristic or rule-based approach, which implies a practical method which is not guaranteed to be optimal, but is sufficient for reaching an immediate short-term goal or approximation. Well, these are different examples of heuristic approaches. Uh, Let me explain the NLP use case of sentiment analysis. Suppose you have a dictionary of positive, negative, and neutral words created by an expert of that domain. In a specific review of, suppose, a YouTube video, you count the number of positive, negative, and neutral words, and based on the count of words, you classify the review using an if-else control structure. And you say that that particular review is positive, negative, or neutral. Uh, you can also use this WordNet, which is a lexical dictionary that contains an organized collection of words and their related words. For example, running, jogging, maybe tracksuit, joggers, these all are related words. Well, this open mind common sense is a knowledge acquisition system designed to acquire common sense knowledge from the general public over the web. Uh, this OMCS is a project of Massachusetts Institute of Technology, Media Lab, and it remained active from 1999 to 2016. Well, this regular expression, this is another way to extract specific patterns like dates, emails, URLs, salutations from large collection of text. Well, my students, heuristic approaches gives you accurate solutions because of human involvement. However, you have to use knowledge and experience of multiple experts to apply the heuristic knowledge effectively on a particular NLP problem. Let me move on to the next approach, and that is uh, the the machine learning approach. Uh, Machine learning era started in 1990s, and it also impacted how the NLP problems were solved in those days. Machine learning algorithms proved better than heuristic approaches because they are capable of defining and creating their own rules. Moreover, machine learning models use statistical algorithms on large data sets and therefore proved better than the heuristic approaches. Last but not the least, heuristic approaches do not work, or rather, they fail to work in case of open ended situations. where there are lots and lots of rules. The only new step that we need to add to solve NLP problem using machine learning approach is that we need to convert our textual data to vectors of numbers. And this is called feature extraction or feature vectorization. And this is shown over here as well. During the training phase, the input text is converted to feature vectors, and along with the label output, it is passed to some machine learning algorithm model to create a model. And during this prediction phase, the new or a test input text is vectorized and given to the already trained machine learning model, which gives you the output label based on the rules that it has learned during the training phase. Well, some supervised machine learning algorithms that we can use in solving NLP problems are naive Bayes, logistic regression, support vector machine, decision trees, and random forest. And similarly, unsupervised machine learning algorithms that we can use in solving NLP problems are k-means clustering, latent semantic analysis, latent Dirichlet allocation, non-negative matrix factorization, and hidden Markov models. Well, of course, we have already discussed some of these algorithms in our machine learning module. If you haven't watched that, please watch that. And let me move ahead and talk about the third approach to NLP. My dear friends, a deep learning era started in 2010, and it completely revolutionized the NLP domain. Other than natural language processing, the deep learning models they produce promising results in the fields of computer vision as well, medical image analysis, bioinformatics, climate science, and in many of the board games as well. Deep learning is actually a subfield of machine learning concerned with algorithms inspired by structure and function of human brain, called artificial neural network. It can be supervised, unsupervised, or maybe semi-supervised. Well, in machine learning, we need to have the domain knowledge in order to do the feature extraction. On the contrary, in deep learning, the feature extraction is done automatically by the model. And the downside of this is if the results are good, you do not know why they are good in deep learning. And if the results are bad, you don't know why they are bad because you have not extracted the features yourself uh, in case of deep learning. However, the advantage of this is you need not to be a domain expert if you are using deep learning approach. Well, another advantage of deep learning over machine learning is that the sequence of information within our text is retained in case of deep learning. And for that, we use word2vec, fast text, and glove for vectorization of our textual data instead of using bag of words or TF-IDF. Well, don't worry about these terms as we will inshallah study these in our upcoming sessions. Some famous deep learning models that we will inshallah cover in our deep learning module are convolutional neural network, recurrent neural network, long short-term memory, gated recurrent unit, uh, and finally the most impactful breakthrough in NLP happened in 2017 when a team at Google Brain introduced the transformer architecture. Well, my dear students, this transformer package is available in PyTorch and TensorFlow. It is provided by Hugging Face and provides more than 30 pre-trained models and support up to 100 languages, along with 8 major architectures for natural language understanding and natural language generation. The two most famous are BERT, that is bidirectional encoder representation from transformers, and GPT, that is generative pre-trained transformer from OpenAI. GPT is from OpenAI while BERT is from Google. Well, I think I have thrown a lot of new terms while discussing uh, heuristic, machine learning, and deep learning approaches to solve NLP problems. Don't worry much. We will cover many of these in our in this course of uh, our upcoming videos, inshallah. And let's see what is left for today's session. Okay. So here is the final part. That is the NLP pipeline, uh, which is a set of steps followed to build an end-to-end NLP software. The pipeline I have mentioned over here has 6 steps: data acquisition, text pre-processing, feature extraction or feature engineering, model building, model evaluation, and model deployment. And then we have model monitoring and falling back to these again. Well, in literature, you may find pipelines where this text pre-processing step is further divided into 2 parts, like text cleaning and pre-processing, and maybe this after deployment, you find another stage, that is the monitoring and model update stage. Moreover, I have shown the arrows in a sequence, but this model is not followed in a linear fashion. Let me quickly describe these stages one by one for better understanding. My dear students, the first and the foremost important step is to acquire data related to the problem which you want to solve, or uh, maybe you want to learn uh, to apply some machine learning or deep learning algorithm, and for that as well you need to have a data set. Well, the first place you should look for data sets for learning process are the toy data sets available in libraries like Seaborn, Scikit-learn, and NLTK. Well, NLTK comes with many corpora, toy grammars, and trained models. And some of the famous corpora that comes built in with NLTK are movie reviews, product reviews, Twitter samples, Gutenberg, Genesis, Time8, Voice, and WordNet. For learning purpose, again, you can look for a dataset from different public dataset repositories like Kaggle, GitHub, data.gov, and the famous UCI machine learning repository. Thirdly, if you are working for a company, you can look for your required data in the company's SQL or NoSQL database. Uh, if you do not find your data from any of these 3 places, you can go for web scraping using libraries like Request, Beautiful Soup, Selenium, and Scrapy. And one more point that you should keep in mind is that if you have web scraped your data or use some web API to get it, your data will not be labeled, and you have to label it manually or maybe using some crowdsourcing services like Amazon Mechanical Turk or LineBridge AI. Finally, if you have generated your own dataset by web scraping or maybe using some IoT sensors, and you think it is not enough for the machine learning algorithm to be trained properly, you can do something that is known as data augmentation, which is a set of techniques to artificially increase the amount of data by generating new data points from existing data. You can also try synthetic data generation by using NumPy or TextBlob. Uh, well, I think enough of discussion on data acquisition. Interested students should watch my YouTube session on data acquisition using web scraping available at this link. And last but not the least, remember, better data often beats better algorithms. Excuse me. Okay, the next phase of our NLP pipeline is text pre-processing. My dear students, text pre-processing helps to remove unhelpful parts of our textual data or noise that will increase the accuracy of our machine learning model. I have divided this phase into 3 subparts. First is the text cleaning, in which you remove digits, extra spaces, HTML tags, URLs, punctuations, emojis, and do spelling correction. Second is the basic pre-processing, which include case folding, expanding of contractions, chat word treatments, tokenization, and removing stop words. And the third part is advanced pre-processing, which includes stemming, lemmatization, part of speech tagging, parsing, and co-reference resolutions. My dear students, our next session will be on text pre-processing, and inshallah we will understand all these concepts with hands-on practical examples, inshallah. And before proceeding to next phase, let me tell you that it is not at all necessary to perform all these pre-processing tasks in our textual data. Uh, which all of these tasks are performed depend on the problem at hand and the available dataset. Okay, my dear students, once our textual data is cleaned, the next step is to convert it into a machine readable format by converting the words into numbers. And this process is called feature extraction from text or text vectorization. For this, we assign numeric weights to the words within our text documents in such a way that the number represents the meanings of those words. We can divide this step into two main categories. First is the frequency based word embedding techniques, which are bag of words, TF-IDF, which stands for term frequency, inverse document frequency, and global vectors, GLOVE. The second category is prediction based techniques, which are word2vec by Google and fast text by Facebook. Once again, which out of these techniques you should use depend on the problem you are solving. For example, for text classification, one can use the old fashioned bag of words with TF-IDF, the famous word embedding with word2vec, and the cutting edge language model called BERT uh, is also an example of these techniques. Okay, anyway, they can also be used. But of course, we will see to those techniques after we have done with our deep learning portion. Okay, my dear students, once we have the data ready to be fed to our machine learning or deep learning model, the next step of NLP pipeline is the model building. I've already talked a bit about these different mm, machine and deep learning models. But $100 question is which out of these models uh, we need to choose for which problem. As a thumb of rule, my dear students, remember that there is no perfect model for our specific situation. So we must seek a model that is good enough. I suggest that if your dataset has a fewer number of observation and higher number of features, choose algorithms with high bias or low variance, like this naive bias or linear support vector machine. On the contrary, if your dataset is sufficiently large and the number of observations is higher than the number of features, you can go for low bias or high variance algorithms like this k nearest neighbors or maybe kernel support vector machines. And of course, there are problem specific algorithms. For example, latent dietary allocation is best suited for topic modeling, and latent semantic analysis is best suited for reducing matrix dimensions. Well, as a beginner, I suggest that you should start with naive bias for all your text classification problems like email spam filtering and sentiment analysis of YouTube video comments, product views, and tweets. Okay, so excuse me. Um, my dear students, after you have done with the training of your machine learning model, the next step is to evaluate model's performance to know its strengths and weaknesses. Well, classification algorithms have a discrete output that can be binary, multinomial, ordinal, or multi-class. So we need a metric that compares discrete classes in some form. So in our machine learning module, we have discussed metrics like confusion matrix, accuracy, precision, recall, F1 score. and this area under the receiver operating characteristic curve. These are the evaluation metrics for classification algorithms. And similarly, regression algorithms have continuous output, and we need a metric that calculate the distance between predicted values and the ground truth. And in our machine learning module, we studied mean absolute error, mean squared error, root mean squared error, and R squared error, also known as coefficient of determination, as an evaluation matrix for all our regression algorithms. Okay, anyway, we will of course see the details of model evaluation for NLP algorithms as well. Meanwhile, let me move ahead. My dear students, the last step of our NLP pipeline is model deployment, which means placing our trained machine learning model into a live environment from where it can be accessed by end users or maybe by other apps through API. Suppose you have trained, tested, and evaluated your machine learning model using sklearn or Keras or maybe TensorFlow. Before you can deploy it, you need to serialize this model object using the Python pickle or job lib module. Then you create a web app using Flask or maybe Django or any other web framework of your choice, and check the working of your app on your local machine. So this is what is shown over here. And my dear students, there is a wide range of cloud services like Amazon Web Services, Heroku, Google Cloud Platform, and Microsoft Azure. And each is offering uh, infrastructure as a service, container as a service, platform as a service, and function as a service. Being beginners, we will use Amazon Elastic compute instance, famously known as AWS EC2, to deploy our web app over here. You can use Google Kubernetes as well, and both are containerized services. And then once it is done, end users can access these services of yours using a web browser, a mobile app, and maybe uh, some other application can access your service using some API. Okay, so I think that is enough for today's session. Fine. I hope now you have a fair understanding of the domain of NLP, natural language processing, and uh, and you are ready to take on the upcoming sessions of this module. My dear students, if you have liked it, please do subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz. See you next time.